So this is a brief introduction of mine, where I'd like to just talk about the current state data storage and data processing literature survey, where I'd like to just focus on what are the drawbacks that are present in the existing data storage and data processing methodologies. Perhaps you might know well because you are facing this issue currently. Well, let us just talk about what are the drawbacks in the existing storage and then switch on to the data processing. And let us just discuss how Hadoop will be a solution for that and what are all the ecosystem components do you require exactly for your case. I'll talk about that. So well, this is a brief introduction of data where I classified the data as people's data and machines data, where we the people generate a lot of data like the data from your social networking sites and the data from your online transactions and all stuff, e-commerce, where we'll be just uploading the images, videos, likes, comments, shares, tags, applications, status, tweets, and your e-commerce. So it will generate a lot of data, and your machines data, where when I talk about the machines, RFID readers, sensors, GPS traces, satellite communications, this will also generate a lot of data. And the log files, which we usually disable at the server level, but using Hadoop we can just generate money out of that dump currently. And this is our a brief introduction of data, and let me just focus on the data storage perspective challenges, where the first word which will strike away your mind is nothing but RDBMS. And indeed, as you spelled that, you have been storing your data in the RDBMS like SQL Server and Oracle, where you might face these challenges like there will be a storage saturation limit, where you can't store a huge magnitude of data and your RDBMS will not give you a very good performance at that large magnitudes. And schema on right indicates whenever you want to store the data, you need to define the schema initially and then you need to upload the data to your RDBMS. And in this scenario, if your schema does not match with your data fields, absolutely you can't store that data. And above all, there is no support for unstructured data, like where you can store your XML files, HTML files, your log files, your images, videos, audio files. So these all comes under the unstructured data. The data on which you cannot define a schema is nothing but your unstructured data. And we usually purchase this RDBMS disk space from the SAN storages, where it is too expensive for providing the data redundancy and for the data storage as well. So the data storage challenges are like there is a storage saturation limit and there is no support for unstructured data, and above all it is expensive. So when I talk about the data processing challenges, we usually store your large magnitude of data in the Teradata or NetAsia, and though your Teradata can process your data in a parallel way, the drawback with your Teradata is of its block size, and you need to transfer the data across the network from the front end RDBMS to the Teradata, where several network constraints come into the picture. Well, the data transfer will lead to a bottleneck problem because you need to transfer the data across the FC cables. Though your transfer rate will be at gigabytes per second, your disk will not support at that much speed. It will be hardly struck at 250 or 500 Mbps, so hence leading to a bottleneck problem, speed bottleneck. And your disk seek time will be a major role, where hardly 8 KB of file system. If you want to retrieve the data, let us consider a Unix file system where we usually follow the data storage perspective. Let us consider we stored 164 MB of data in your Unix file system, which will consume 8,000 Unix file system blocks. And when you want to retrieve that 64 MB of data back, your disk head need to be moved 8,000 times, where the time taken by your disk head to retrieve your data from one block to another block is what we address as disk seek time. So the disk seek time will be more at this scenario, and the speed transfer will be a bottleneck. So on an average, this is our overall discussion, where there is no support for unstructured data and your disk seek time is very large, and your network constraints and your expenses. So we need an alternative which will vanish your disk seek time, which will eradicate your network issues, which will support the unstructured data, and which will not be expensive. And that is your Hadoop. And well, I know this, I think you might even know this. Perhaps you might have heard about this organization, IDC, several times. And according to the statistics of IDC, in the year of 2006, the world's data is of 0.18 zettabyte. And in the span of 5 years, that is in 2011, that is of 1.8 zettabyte. That means 5 years, it almost increases 10 times. By the end of 2020, they're expecting this to reach 40 zettabyte, where 40 zettabyte equals to almost approximately 4 into 10 power 10 terabyte, because 1 zettabyte equals to almost 10 power 9 terabyte. So 40 zettabyte equals to 4 into 10 power 10 terabyte. So the data storage becomes very typical, and the data transfer rate with the existing bottleneck problem becomes a wrong thought, and it becomes too expensive to process this much magnitude of data. And we need an alternative at these perspectives. That's again for your Hadoop, which will have both data storage and data processing at one hub. And about 80% of this data will be the unstructured data, where the data is being generated from the social networking sites and your e-commerce sites will be the unstructured format. And we classified the mails as semi-structured data because when you consider a mail, we can define a schema on the to CC, BCC, and from fields. We can define a schema on it from the addressing fields. But where we cannot define any schema on the text body, where you cannot define the schema on the attachments, because even some mails may have attachments and some may not have an attachment. And the attachment might be an image file, it might be an audio file, it might be a video file, where you cannot define a schema on this. And the machine's data, as discussed, processing the log files will generate a huge revenue for the e-commerce, where we processed those log files for Flipkart and we generated almost 32% of their revenue. So this is the range of your Hadoop. So perhaps you might have even heard about this data, big data. I think that might be the problem even you're facing now, where whether if your data has 3 characteristics, like if your data is of large volume, ranging from terabytes, petabytes, exabytes, and even at the range of zettabytes, whether your data is of semi-structured or unstructured format, and if your data is improving at high velocity, at high factors, so you can address your data as big data, and it is your Hadoop which can handle this big data in a well-versed way. Well, let me just share how Hadoop will be an alternative by overcoming all your existing data storage and data processing drawbacks, and how it will handle the big data problem. Well, Hadoop is always at a cluster level, point 1, where a cluster is nothing but combination of nodes across a network, and a node is nothing but a computer. So let us just make it simply like this. And a cluster is nothing but combination of computers connected across your network, and when you install Hadoop on each and every computer, it will simply become a Hadoop cluster. And whatever the node you are attaching, and this cluster is of commodity hardware, cheap hardware. It does not require any hardware like blade servers and Spark processors to work on. Your Hadoop will work with normal hardware. It need to have very minimum requisites. That's the main reason why I could able to install Hadoop on my laptop, and even on the day 5 of our journey, we'll be installing Hadoop on your laptops or your PCs, because yours is a commodity hardware, mine is the commodity hardware, cheap hardware. And above all, Hadoop is an open source through Apache. Well, Hadoop have 2 major components within it, HDFS and MapReduce, where HDFS stands for Hadoop Distributed File System, where the default block size is of 64 MB, unlike the normal distributed file systems. Since the block size is of 64 MB, the time taken by your disk head will be almost vanished, and your disk seek time will be almost eradicated because of the largest block size. And since you are storing your data directly in your file system, there is a support for your unstructured data as well. And Since you are storing the data and you are processing the data on the same cluster, using MapReduce, you can process the data, whatever that was stored in your HDFS. Since you are making the both at the same cluster, yes, your network issues will almost eradicate it. So there is no expensive, because your expenses will come down because of the commodity hardware and open source, and you could able to store your unstructured data because you are storing your data directly in your file system. And since you are storing the data and processing the data on the same cluster, you will not have your network issues, and because of the largest block size, your disk seek time will be vanished. So all your 4 drawbacks will overcome within this. And this is what I've been talking about: data storage and data processing at one hub. That is nothing but your cluster, where it is the fastest processing. Well, this is not what Vignesh is boasting about Hadoop. This is the IBM's declaration, where we processed 1 terabyte of pure unstructured data with RDBMS, which consumed 28 hours to process it. And we processed the same 1 terabyte of unstructured data using Teradata, which consumed 6.5 hours to process it. The same 1 terabyte of unstructured data using Hadoop, a 180 node cluster, consumed 3 minutes 27 seconds to process it. The same 1 terabyte of unstructured data on the same 180 node Hadoop cluster, but using latest architecture, YARN, on top of Hadoop, we consumed just 1 minute 19 seconds to process it. That is the place at which Hadoop can make it, and above all, we could achieve that at a cheap cost because of the commodity hardware. Well, this is what exactly do I mean by Hadoop. So whatever the data you'd like to just deal with Hadoop, when you upload that into Hadoop, your data will be broken into 64 MB blocks, and these blocks will be scattered among the slave nodes, exactly the nodes of your cluster, and these blocks will be stored on these nodes. And when you want to process the data, you'll design a simple computation, writing a simple MapReduce program, and it's your jar file which will travel towards your data, and it will be processing parallelly. On a simple view, it's a parallel processing, but if you delve much more deeper on each and every node, your data will be still more parallelly processed. The data will be still more parallelly processed on each and every node by having some instances. So that's the main reason why we address this as a massive parallel approach. So HDFS is a distributed file system for storage, and MapReduce is a massive parallel approach to process the stored data in your HDFS. And this is the core concept of Hadoop, where it is easier to move the computation rather than moving the data. That's what we have been doing here. It's your computation which is approaching towards your data, and your data is stagnant. And it is massive parallel processing for ease, for the fastest processing, and it is easier to deal with small data pieces rather than dealing with big data sets. That's what we have something called as HDFS splits. Your data is broken into 64 MB blocks, and further you have something called as input splits to work on. And above all, you could get with commodity hardware, cheap hardware. And this is a quite common question what I usually face from many of the people. They usually ask me that why should we go for a new framework called as Hadoop? Rather than that, why can't I achieve the same parallelism using a combination of n number of disks installed with databases, and I'll process each and every disk parallelly? Yes, it's a very good thought. They can do it, but what about the disk seek time? And what about the data type where you can't store your unstructured data? And what about the redundancy, which will make it expensive? So we need an alternative. And perhaps this will suit you, where you like to migrate your project for RDBMS to HDFS storage. We have an ecosystem component called as Scoop, and where using Scoop you can import all your tables from your RDBMS to HDFS, or you can import the specific tables from your RDBMS to HDFS, and even you can import the data using the where clause as well. So you can have it using Scoop, and even Teradata connector. You can even import the data from Teradata to HDFS. You need to integrate the Teradata connector with Scoop. So those are all the privileges what you get using Scoop. And for the people who are not from any programming background, because we usually design the MapReduce shop in Java, Ruby, Python, Perl, or even in C++. So if you have the people who are not from any programming background, and if they still want to deal with Hadoop, yes, they can go ahead. We have something called as Hive ecosystem component, which is almost like SQL, and whatever the query you write, that will be internally converted into a MapReduce job. And we have some other ecosystem component called as Pig, where whatever the script you write, that will be internally converted into a MapReduce job. Pig has its own scripting language called as Pig Latin, and whatever the script you write, that will be internally converted into a MapReduce job. And like your Scoop, we have some other component called as Flume, which will be installed on the servers to import the data from those to your HDFS, no sooner when they were generated. And we have a NoSQL databases could be integrated with Hadoop, where we have almost 150 NoSQL databases, out of which the most sounding one are like HBase, Cassandra, MongoDB, Neo4j, Couchbase DB, Accumulo. So these are all the most sounding NoSQL databases, where you don't have anything like normalization, no primary key and foreign key, where you can store your unstructured data in key value pairs. So HBase is one among them, the NoSQL databases, and Avro is the ecosystem component to deal with the serialized data. It was through Cloudera. So each and every ecosystem component what I addressed are open sources, and your Hadoop itself is an open source here. But since this is an open source, if you have any technical issue while working in the production environment, you'll not get any technical support for that. And since this is an open source, you can't expect a very good GUI for this. And since this is an open source, if you want to work with these ecosystem components, you need to download each and every ecosystem component, you need to install it, and you need to configure it. And in this due course, if you have an issue, no technical support. Owing to this, there are several organizations which came forth, where they will offer you a very good customer support, an excellent GUI, and they will give you all the ecosystem components as a package. And some of them are like Cloudera, Hortonworks, IBM's Big Insights, Microsoft HD Insights, Amazon Web Services, EMC Square's Hadoop, and you have HP Vertica, Intel Hadoop, Teradata's Astrodata, Oracle Hadoop. We have almost 14 distributions like this. So these are all the wide range of distributions what your Hadoop offer for. And these are some of the organizations where Hadoop has been already implemented, and even several organizations are even switching on to Hadoop. If they still want to exist in this data world, they need to migrate for Hadoop. So this is a brief introduction, and if you have any queries, now you can fire me with your queries. Please go ahead. Please go ahead.
As you said, yeah, I'm Sanjay Desai.
Yeah, please.
Thanks for this very interesting and informative session. And my first query is, as you said that this is an open source, and some companies have made a package of it, and they are, offering it to different clients. So, can you tell me whether that package has got some license, sort of a thing like that normal Oracle RDBMS, they provide no Oracle per client, some sort of thing? Or is it something, as an organization, you can buy it?
Right. So if you just go for Cloudera distribution of Hadoop, it is absolutely free. They'll not charge anything if you have the cluster sizes of 50 nodes. Until the 50 node cluster, they'll not charge you anything. And they'll charge the amount if they want to come to your organization, and if they need to fix your problem. For that, you'll be charged the money. Until then, they'll not charge you anything. they'll give you a customer support which you can configure it. Even the same for all the organizations.
Okay.
The most of the sounding, the most successful distributions among these distributions are Cloudera, Hot and Wix, and some are even following the big insights, and some are following the Vertica, HPs. But major one is Cloudera.
Okay.
Please go ahead. You can fire me. Please go ahead.
Just one question.
Yeah.
How to start the implementation of this whole system in our organization? Because right now we don't have any experience in this technology. So I was checking this Apache website, and I have all those files also of Hadoop from Apache this website.
Right.
So how to go about this thing? Is there any resource or some online book, I mean, like from very scratch we can try something?
So
Because,
if you want to
exactly
build your
like,
cluster,
yeah.
would you like to build your cluster, build the cluster in your organization?
Yes, I just want to test it first.
Right, you'd like to just use it for a POC.
Sort of POC?
Yeah, is that right? It's for POC?
Yes, currently we have one setup, okay, where we are using this SQL server, and fetching the data from that SQL server is sort of very time consuming. So,
right, if you want to, yes, if you want to have much more faster accessibility from HBase, you need to customize that using your, you just write a simple Java code for that, and where you need to store the data in the H files, and you can even integrate that HBase with Hive, where it will give you a very good accessibility for the large magnitude of data.
How to
you can
go
follow
about
that.
I mean, how will I do that? Writing that thing in the HDFS. Is there any book like Hello World type of book, some which can help?
So you'd like to just know about the books which will give you the knowledge of Hadoop?
Yeah, because I want to try this.
Right, you can just go ahead with Hadoop Definitive Guide, have a peep through that. It will just give you a very good support.
Which one?
Hadoop Definitive Guide.
Hadoop? Hadoop Definitive.
OREL's Hadoop Definitive Guide.
Okay, OREL's.
You have Hadoop Definitive Guide, you have Hadoop in Action, so you can follow either of these books.
Okay.
So you can follow these books. They are